Hello, my dear pilot friends. I'm sure you must be doing well in your studies and also in your flying training. Our association is going stronger now, and we'll make it even more stronger by learning more and more of the lessons. Now, here you are, and to remind you, welcome to Booty Aviation Training, and we are doing a series on navigation numericals. And here I'm back with you, and today's topic is ADF, Automatic Direction Finder. This is one of the navigates which is virtually on the way out, but is still being used in many airports around the world. And this is the first navigation aid in direction finding which we learn, and then go on to VORs. Okay. What is an automatic direction finder? There is a transmitter on the ground called NDB, non-directional beacon, which transmit waves all around, that is omnidirectional radio waves, which are picked up by your aircraft, and your aircraft is able to identify which side is the ground station and shows it to you on the indicators. Direction finding was earlier known as radio compass. Okay. I am interested in my bearing to the station or from the ground station. Where am I? Ground station to the aircraft, that bearing measured from true north is called QT. Measured from magnetic north is called radial or QDR, magnetic bearing. Reciprocal of QTE, that is from aircraft to the ground station, true bearing is QUJ and magnetic bearing QDM. What does this indicator measure? The automatic direction finder measures the relative bearing, that is with effect from the nose of the aircraft. What is the bearing of the ground station, which can later be converted into a QDM, QDR, QTE, or QUJ. So aircraft knows to the station that bearing is called relative bearing. And the simple indicator, one of the most simple and the olden types, is known as the fixed card relative bearing indicator, in which the north appears on top, and this is the aircraft direction. That means this is my nose. From my nose, it shows you that this station is in this side. Then there is a movable card which has got this knob with which I can set a heading on top. And if I set the magnetic heading on top, this arrow will indicate QDM of the station. And if I set true heading, the arrow will indicate the QUJ to the station. When it is showing you QUJ, the other end of the needle will show you QT. When this is showing you QDM, other end of the needle will show you the radial. How nice. Now, improved versions today have a radiomagnetic indicator in which the pilot does not set the heading, but the heading is synchronized with your gyromagnetic compass and your current magnetic heading being flown. Remember, magnetic heading being flown is shown at the Lubber index on top. And now your needle shows you cubic delta mic of the station, and this will give you the radial. It has a provision for two needles. You can connect one to ADF, one to VOR. You can connect both to VOR, both to ADF, depending upon what is fitted in your aeroplane. So that is the radiomagnetic indicator, right? What is the relative bearing indicator? This needle is still showing you relative bearing, but since the QDM has come on top now, it has started showing you QDM. Magnetic heading is on top now. Now this relative bearing is now from the magnetic heading, and therefore it becomes QDM. Now, illustration, simple illustration. This is the north. This is my heading. If this is magnetic north, this will be my magnetic heading. True north, then it will be true heading. And when I tune the station, okay, on my control box, the needle starts pointing towards this side. Gives me a relative bearing of 090. That means the needle is pointing here. Relative bearing indicator, RBI. Now this is my relative bearing. Magnetic heading plus relative bearing will give you QDM if my heading is magnetic. True heading plus relative bearing will give me QUJ. In this case, if my true heading is 050, relative bearing 090, then 140 becomes my QUJ. Now, what do I do with this? If I want to fly to this station, magnetic track will be 140. And if I want to fly a true track, I'll fly a QUJ. If I'm flying, this is true. If my heading is true, then this becomes my QUJ. Right. And if I'm not interested in going to the station, I can plot a line in this direction, and which will be crossing my track at this place. I know I'm somewhere on this line, which is called line of position, in the direction of reciprocal. QT was 140, so this will be 320. Draw a line in the direction of 320. If you have a DME, distance measuring equipment, cut it here, this line here, and that gives you a fix that I'm in this direction. That is called line of position or bearing, and my distance is so many nautical miles, and I get my fix, which is called a radio fix. Fine. So one of the uses which you have read now is I can find out my QT, QDR, QJ, and QDM with the help of ADF. What else can I use it for? I can also use it for finding out my ground position, my fix, radio fix. This is my track, left to right or right to left. And on my track somewhere here, I select two stations, which will give me approximately a 90 degrees cut. And I take the bearings from these two stations. And if it's a true track, I will convert them into QTs and plot. This is where they cross. So here is my aircraft at this moment. If I'm going from right to left, destination is to the left, then this is my distance off track to the right. And if I'm going this side, then this is my distance off track to the left. With this, I can now find out my track error, remember 1 in 60 rule, and find out the closing angle and apply a correction. If this appears on my track itself, I find that this fix is on my track itself. Very nice. That means I am on track. Here it is. No correction is required. Okay. Good. So 1 in 60 rule we'll be using in these numericals. Second is I can also find out my position with the help of taking bearings of 3 NDBs and converting them into true bearings from the NDB and get a fix. 2 lines of position should cut approximately at 90 degrees for a good fix, and 3 position lines or lines of position should cut each other approximately at 120 degrees for a good fix. So I can fix up my position. Can I use the ADF for something else? Yeah, many uses. I can track in and out with the help of ADF. When this is my aircraft, this is the departure I have taken, this is the station, whatever is the track, 240, 120, 180, and this is the destination in front of me, and this is my aircraft at the moment here. If I'm flying under nil wind conditions, then my heading, my nose will also be pointing towards here, destination. In nil wind condition, station behind me, departure station on the ADF will read 180 degrees. The station is behind you. And destination will read 360 or 000. If there is a drift, then let's say this is the case. There was a drift port I calculated, so I offset my nose to the starboard. Take for example 10 degrees. Now my heading will be 10 degrees more than the track. ADF will still be pointing towards this point, which will be 10 degrees to my left or 10 degrees less. So when there is a port drift, my heading will be more or to the starboard, but my ADF reading will be less by that much amount. Station behind me, 180 less the drift. If drift is 10 degrees, this station will read 170. See from the nose, this angle is 170. And this station will read 350, 000, less the amount of drift. If now it is reading 180 here, that means you are not on track. Because you have applied the drift, there is a drift, that means you have reached actually here. So best way is, okay, find out apply the magnetic heading bearing relative and find your QUJ to this station or QT from this station, and then you will know whether you are on track or not. If this track was 240, from the station behind, if you calculate QT of 240, you are on track. If QT is 250, you are 10 degrees to the right of the track. QT is 235, then you are 5 degrees to the left of the track. Similarly, if there is a starboard drift, heading will become now less than the track, heading will go to the left, and ADF reading will become more. Station behind will show more than 180. How much more? Drift. Station ahead of me, 000 plus the drift. That is the way I can track in and out. As long as my ADF is reading the amount of drift, I am on track. Right. Next use is I can report this ADF for a position reporting, a beam ground station or a NDB. When do we say we are stationed abeam? When your angle between your track and the radio, it becomes 90 degrees. So now what I should look forward is when I'm going on this track, the station comes to my right, relative bearing should be 090, but that is only under nil wind. If my heading is to the starboard to compensate for the drift, then the relative bearing will be that much less. Now, if my heading is to the left, drift was 20 degrees starboard, I put my nose 20 degrees to the left. Now from my nose, this station should read 090 plus 20 degrees. Nose has gone to the left, NDB reading should become more, and report your position abeam with that relative bearing. Right? Now, next is your time to the station. When you're crossing a station abeam, Can I find my time? How much time do I need to the station? Yes, I can. This is the aircraft on this track. There is a NDB coming to his left abeam. It could be to the right. If it is to the right, then at this moment, my relative bearing is less than 090, and here relative bearing will become 090. If it is to my left, at this moment, my relative bearing will be more than 270. Let's say this is 290 in this example. When I reach over here, needle will show to the left 90 degrees and relative bearing shown will be 270. Note down this change in bearing and also the time in seconds. I can find out the time to this station. Time to the station in minutes will be time in seconds for the bearing change and divided by the bearing change in degrees and into 60 will give you time in minutes to that station. To find out the distance of the station, this time in minutes multiplied by ground speed per minute, and that is when you'll find the distance of that station. Example, 300 seconds if I have taken this time for a bearing change of 20 degrees, 300 by 20, that means now at this moment, my station is 15 minutes from me and into ground speed by 60, that is ground speed per minute, you will get the distance. So remember, time in seconds divided by bearing change into 60 is time to the station and multiplied by the ground speed per minute. This time in minutes multiplied by the ground speed per minute is the distance of this station. Once you then know the time in minutes, sometime you could ask you, okay, this is my fuel consumption. How much fuel do I need? So find out, this is my fuel consumption per hour. How much fuel I need for this time? Those type of questions are also asked. And with the help of this, they can relate it to a 1 in 60. If your ADF is not reading the proper amount of drift, then apply the formula bearing relative plus the heading true is QUJ, opposite is QT, plot the QT. If it is not your track, if QT is more than your track, you are to the right, less than your track, you are to the left, and that will give you the track error, and then find out distance gone and distance off track and correction to the destination. If you are finding it little difficult, go to your lesson on 1 in 60 rule. Now, this lesson, I will leave it here for the time being. And I would like you to read it a number of times before you attempt the numericals, which I have given you in next lesson. Now, before you log out, don't forget to like and subscribe the channel, like the videos, and also share the link with your pilot friends in your groups of pilots and flying clubs. If you have understood the lesson, otherwise read it twice, you will understand. Then go over to the next video, that is lesson 28, to test your knowledge. For the time being, this is SK Booty wishing you happy landings, good luck, all the best, and see you in next lesson very, very shortly.